Hello friends. Today we'll learn about how the engine uses the scene tree to run our scripts. I haven't yet attached a script to the root node of the scene tree, but will instead start this lesson by adding more nodes. Right-clicking on the root node, then selecting Add Child Node, still just a normal node, we can rename it to be President and pretend our scene tree is the structure of a company. The President node is indented because it is a child of the scene's root node. With a node selected, we can also use the shortcut Ctrl-A or Command-A to add another child node. Let's name this one Operations Manager. And it is indented another level because it is a child of the President. Let's now attach a new script to the President node and name it Employee. Overriding the base node's definition of the ready function, we can simply print the name of this node and append isReady. This script can be attached to more than one node, so let's attach the same script to the Operations Manager node by dragging it from the File System tab to the scene tree. Then run the scene to see what happens. We can see that the Operations Manager is ready, then the President is ready. Both nodes that have the script attached run the script, and since they have different names, the output was different. We can also see that the Operations Manager was ready before the President was ready. To understand why, we'll need to add more employees. The Operations Manager will oversee a number of operators, so I'll add another child node to the Operations Manager and name it Operator 1, then attach the employee script. We can right-click on any node except the root node and select Duplicate to create a copy of it. The duplicate's name will automatically include an increasing number, so we can have operator 2, 3, and 4, etc. Since the node we duplicated had a script attached, the copies created also have the same script attached. Since the operators have the same indentation level and are all children of the Operations Manager, they are called siblings, and siblings are not allowed to have the same name. Our company should have more than one department, so let's duplicate the entire Operations department by duplicating the Operations Manager. All of the child nodes are also duplicated. Since the operators are not direct siblings, they are allowed to keep their original names. Let's rename the manager to be Marketing Manager, and they will have just 2 marketers working on their team. Parent nodes can also be collapsed to hide their children or expanded to show them. All of the employees of this company have the same employee script attached to them. So let's run the scene and get a better idea of the order in which the scripts will be run. We can see that the first operator is the first to be ready, followed by each operator in sequence, and finally the Operations Manager. The same follows for the Marketing Department. Then finally the President of the company is the last to be ready. How is Godot deciding this order of execution? The engine starts at the top of the scene tree and works its way down. But it does not consider any node to be ready until all of its children are ready. So the President is not ready because the Operations Manager is not ready. The Operations Manager is not ready because the operators are not ready. The operators are ready in sequence, since they have no children. Once all of the operators are ready, then the Operations Manager is ready. But the President still isn't ready because the President has another child who is not ready. The Marketing Manager was not ready until all of the marketers are ready, and finally the President is the last to be ready. Since the root node doesn't have a script attached to it, its ready function is that of a default node, which is empty. Besides ready, there are other functions of node we can override to be executed later after a node is ready, the most common being process, also preceded with an underscore. The engine will try its best to run the process function of every node in the scene tree 60 times per second, using the default project frame rate. So process uses a parameter named delta, which is a floating point number, to represent the number of seconds that have passed since the previous frame. So most of the time it will be 1/60th, but not always. We do not need to use this parameter for anything today, so we can precede the name of this parameter with an underscore, so Godot knows that we don't need to use it and shouldn't bother with it. But in order to override the process function, it must have the same number and types of parameters. Let's tell our employees to do some work every frame by printing out a statement saying their name appended to does work. Running this scene, we see that all of our employees are working very hard, writing their print statements 60 times per second. This is not the same as an infinite loop, as work is actually being done the way it is intended and nothing is broken. Let's make this a little easier to understand by only allowing each employee to do one unit of work using a Boolean variable, has done work, with a default value of false. In the process function, if the employee hasn't done any work, then they will do work and change the value to true. 1/60th of a second later, since the variable is true, they will not do work anymore. But if we declare this variable inside the process function, then it will only exist inside the process function, and only for one single iteration of it. Next frame, when the process function is run the second time, the variable is declared again and still defaults to false. So this will have no effect. For our variable to persist, it needs to exist outside the context of the process function. So we'll declare it outside the function without any indentation. Variables declared here can be accessed anywhere in the entire script. This concept is called scope, and is one of the main reasons why we use indentation in our scripts, so we can see which variables exist within which scope. Running the scene now, we can see each of our employees declares that they are ready to work, then only once everyone is ready, they each do one unit of work, but now in a different order. The order in which nodes in the scene tree execute their process functions follows the exact order of the scene tree from top to bottom. Parents do not need to wait for their children like the ready function. We may want all of our company's employees to be similar, but not exactly the same. The work of a manager isn't really the same as that of a worker. We can use inheritance to create different behaviors for similar objects, in the same way we are writing scripts that extend node, but changing how they get ready and how they process. First, we need to give this script a name that we can use as a reference, using the keyword className, followed by a name that describes the behavior of the script, usually the same as the script name, but written in upper Pascal case. Now that the engine knows this is an employee, let's create a new script and name this one Manager. But instead of inheriting from node, this time we can inherit from employee. Because our manager script extends employee, everything written in the employee script will still apply to this one. But we can add more or make changes. A manager is still an employee, but the way they do work is different. We should replace the script attached to our manager nodes with the new manager script. Let's override the employee's definition of the ready function, so when a manager is ready, they won't just say they are ready, but they will say that their entire department is ready. In order for both of our managers to be able to output the name of their departments, they will need a variable to hold the name of their department as a string. But how can we populate this variable to hold different values for different departments? If we precede our variable declaration with the tag @export, this variable will become accessible by other parts of the Godot engine, namely the inspector panel. In order for a variable to be exported, it must be declared at the script scope level. Selecting the operations manager in the scene tree, there is now a field in the inspector panel where we can give the department variable a string value. This way, the operations manager and the marketing manager can each have their own value for this variable that we can easily control. Running the scene, we can see that the nodes, which have the manager script attached, now declare that their department is ready, while the other employees all use the previous definition in the employee script. The process function in the employee script is also inherited by the managers, and is run the same as before. So let's change our manager's process function. Managers will say something different. Name plus manages workers to do their work. The has done work variable from the employee script was also inherited and does not need to be declared here to be used. In fact, we can't declare a variable with that name since it would cause a conflict with the inherited variable of the same name. Let's run the scene again and see how our managers now do their work differently from other employees. In the next lesson, we'll learn more about using nodes in the scene tree and object-oriented design principles. I'll see you in the next lesson.